Okay, today we are going to discuss what are the oxidation number rules. There are 6 oxidation number rules. So the first oxidation number rule is that the oxidation number of any uncombined element is 0. Uncombined elements. If you take uncombined elements, their oxidation number 0. Oxidation number is 0. So if you take an example such as acid, chlorine gas, zinc, copper, light metals, hydrogen gas, carbon, so all these have the oxidation number 0, right? So the second rule is there are some compounds, some atoms in many compounds, they have fixed oxidation numbers. Fixed oxidation numbers. So when it comes to the fixed oxidation numbers, group 1 elements, they have the oxidation number always +1. Group 2 elements, they have the oxidation number always +2. And if you take fluorine always has the oxidation number -1 because this is more electronegative, right? This is the most electronegative element in the world, so it has the lowest, that means it always has the highest electronegativity, therefore it always like to be in the reduced state. So when it comes to hydrogen has the oxidation number +1. And when you see hydrogen, if you take hydrides such as sodium hydride, so in this case when you see group 1 metals, they have the oxidation state +1. Therefore if this is +1, this should be -1. So in this instant, when it comes to hydrides, the oxidation state of hydrogen is -1. Except for that thing, all the other states, oxidation state of hydrogen is +1. And when it comes to oxygen, its oxidation state is -2, but except in fluoride, right, F2O. So in this case, fluorine has the oxidation state -1, therefore oxygen get the oxidation state +2. Except for this compound, all the other oxides and oxygen containing compounds, the oxidation state of oxygen is +2, right? So this is the second rule. And the third rule is when it comes to the monoatomic elements, monoatomic ions, when it comes to the monoatomic ions, charge will be equal to the oxidation state. So their charge equal to the oxidation state. So oxidation state is equal to the charge. So this is for monoatomic ions. So if we take air for an example, if you take something like Al3+, so the oxidation state is +3. If you take ferrous, the oxidation state is +2. If you take ferric, the oxidation state is +3. Likewise, for monoatomic ions, always the oxidation state equals to the charge. Then the fourth rule is the sum of oxidation numbers in a compound is 0. Sum of oxidation numbers in a compound is 0. Compound equals to 0. For an example, if you take sodium oxide, there the total oxidation state will be equal to the 0 because there will be no any charge. So sodium has +1 into 2 and oxygen has -2. So +1 into 2 plus 2 plus -2. The total oxidation state equals 0. Suppose something that you don't know, such as sulfur dioxide. There you don't know the oxidation state of sulfur, but you know the oxidation of oxygen is -2 always, except for F2O. So here you can name this sulfur as X plus -2 into 2 equals 0, X minus 4 equals 0, X equals plus 4. Likewise, you can calculate the oxidation state, unknown oxidation states of elements by using this. So this is for the compounds. Suppose ions. In the case of ions, that is the fifth rule, it says the sum of oxidation state of an ion, sum of oxidation states of an ion is equal to the charge of the ion. The charge of the ion. So if you take something like permanganate, there you don't know the oxidation state of manganese. So you can call it as X, and you know the oxygen, it's -2. -2 into 4 times equals to the charge. Charge is -1. So you can equal it to -1. So X minus 8 equals -1. So X will be equal to +7. Another example, if you take something like dichromate ion. So in that case, you have 2 chromiums. Therefore, you can name it as 2X plus, you know oxygen is -2 always. So -2 into 7 equals the total charge, that is -2. So 2x minus 14 equals -2. So 2x equals 12. So x will be equal to +6. So it is necessary to put plus or minus sign. Whether it is plus or minus, you have to say either plus or minus. So in when you are mentioning an oxidation state, you have to include the plus or minus sign. Okay. So the last rule will be whether it is in a compound or an ion, more electronegative element get the negative oxidation state, is getting the negative oxidation state. This is how. If you take something like sulfur dioxide, there oxygen is the more electronegative element when you compare sulfur and oxygen. Therefore, what happened is oxygen is getting the negative oxidation state -2. But as I told you, if you take F2O, their fluorine is the electronegative element. Therefore, it will get the negative oxidation state. Therefore, oxygen has to get the +2 oxidation state. Likewise, more electronegative element will get the more negative sign. So, if you take something like H2O, there hydrogen getting the +1 and oxygen is getting the -2 because oxygen is more electronegative compared to hydrogen. But when it comes to something like sodium hydride, their sodium is less electronegative compared to hydrogen. Therefore, sodium is getting the plus sign and hydrogen is getting the minus sign. So, always more electronegative element will get the negative oxidation state. So, oxidation states are very important when you are balancing equations and when you are going to predict whether it is a oxidation reaction or a reducing reaction. So, oxidation state will give you some idea about how much it is reduced or how much it is oxidized when you see an element, because in the first rule I said normal elements will have the zero oxidation state. So compared to the element in a compound, how much it is get oxidized or how much it is get reduced can be determined using oxidation numbers. So in the next video I am going to discuss how we are going to balance the redox reactions by using these oxidation states. So thank you all for watching.